Hey guys, today we're going over natural numbers and how to represent them using exponent notation. Now, there's two forms of representation of natural numbers that you need to know for the Australian Year 7 math curriculum, and we're only covering one of them today. The previous one, which is products of prime factors, is in my previous video, so you can check that link in the description if you need. Okay, let's get to it. Okay, so first let's go over natural numbers and what they are. They're simply all of the whole numbers from 1 to infinity. So just like that, pretty simple. It goes all the way up, whatever number you can think of, but it doesn't have decimals and it doesn't have fractions, okay? And natural numbers fit into number theory here. You don't need to know this, but that's where they fit. Now, we can represent all of these numbers using exponent notation. And not just these ones, I'm talking about the numbers that are huge. Now, what exponent notation is when we take a number like this and we represent it by using 10 to a power multiplied by each of our digits. Okay, so say for example this 3 here, it's 1, 2, 3, 4, 5, 5 digits after the 3. So what we would do is we do 10 to the power of 5 and then multiply this by 3. And that would be equal to 3 with 5 zeros after it. Just quickly, if you didn't know it already, this 10 to the power of 5 means 10 times by itself 5 times. And when we do that with a 10, it's a really nice number because it will just go 10 and then we'll add 5 zeros. Or we'll just have 5 zeros, sorry. That's just 10 times 10 times 10 times 10 times 10. We'll do plus 10 to the power of 4 times 4. 2 4 is kind of confusing, but this 4, the power of 4, is because of the amount of digits after this 4, and this 4 is because of the place value of the digit here. Okay, the place value is just what number it is. Okay, so now we're going to move on to this 2, and that has 3 digits after it, so we're going to do 10 to the power of 3 times 2, and we'll do the 4, 2 digits after the 4, so 10 to the power of 2 times 9. Now we're going to do the 9, and we're going to do just 10 because there's an invisible power of the 1 here, but we're going to leave that out, times 9, and then the 7, it's just a 7, so we're going to do plus 7. So this may seem like a very silly way to represent this number. It's obscenely long compared to just writing this number. But what it's trying to do is trying to help us understand that this 3 here has a value of 30,000, but the digit is a 3. And so this 3 is actually worth 3 to 10 to the power of 5, which is 300,000. So let's write that. And now let's do the next digit, which is a 4. So place value of 40,000, but the digit is just 4. So this 4 here, it is a 4, but it has a place value of 40,000. Okay, so 300,000 plus 40,000. Whoops. And then we'll do the 2 next, which is worth 2,000. Then we'll do the 4 next, which is worth 400. Then 90. Then 7. If we add all this up, we'll just get this number again. So really easy exponent notation, but the Australian Year 7 curriculum, you need to know this, okay? So let's just go over a couple examples in case you didn't get it the first time. Okay, let's start off with an easy one. 5,742. Now, this 5 has 3 digits after it, so we're going to do 10 to the power of 3 times 5. Now you'll see this 5 matches our digit, but the place value is 5,000, so we multiply 10 times itself 3 times, so 10 to the power of 3, because that gives us 1,000, so 1,000 times 5, 5,000, and we have that. Now let's move on to the 7. Now it's got 2 digits after it, so 10 to the power of 2 times 7 plus 10, because it has 1 digit after it, because there's an invisible 1 here. It's just 10 times itself once. It's just 10. Okay? Plus, times 4 plus 2, because it doesn't have any digits after it. And this will just result in us getting this number again. Okay, let's go over one more example. Let's do a really easy one this time. Let's just do 624. So let's start with the 6. 6 times 2 2 digits after it. So it's going to have 10 to the power of 2 plus 2 times 10 plus 4. Pretty simple. Let's go over all the terms one more time again though. So the digit, it's just a 6, right? That's just the number here for the 600. Now the place value is 600. The digit is 6, the place value is 600. And when we take that to exponent notation, we see that there's 2 digits after it. So we do times 10 to the power of 2. For the 2, we do times 10 because there's 1 digit after it. And for the 4, there's no digits after it, so we don't times by 10, okay? So that's been exponent notation. It's pretty simple, but you need to know it for that grade 7 Australian maths curriculum, okay? So thanks for watching the video. Please leave a comment, let me know something, and see you in the next one.